Hi, this is PP Rao from Enjoy Learning. Today I would like to give a brief introduction about acids and bases and the indicators to know which is acid and which is base. In daily life, we use oranges, tamarind, grapes, lemon, and apple cider vinegar, tomato juice, and aerated drinks also. So these are belongs to acids we use in daily life. What about bases? We use toothpaste, washing soda or baking soda solutions, and detergents, antacids and cleaners, milk of magnesia, lime water, all these belongs to bases we use in daily life. As per Arrhenius theory, what is acid? Acid is a compound that contains hydrogen and produce H plus ions or H3O plus ions when reacts with water. These are called hydronium ions. A strong acid is a water soluble compound that completely disassociates to give H3O plus ions, and a weak acid is a water soluble compound that dissociates only partially, producing few hydronium ions. These are called acids. Acid that contains hydrogen and produce H plus ions. As per Arrhenius, what is a base? Any compound that contains a metal and hydroxide group and produces OH minus ions, hydroxide ions when dissolved in water. All hydroxides are strong bases because the dissociation reaction go essentially to completion. So look at this image. Base is a metal and hydroxide group and produce hydroxide ions. How do we find which is acid and which is base? To know this, we use indicators like natural indicators, synthetic indicators and olfactory indicators. First, natural indicators. Natural indicators are obtained from plants. For example, turmeric, China rose, red cabbage and grape juice, etc. In acid, turmeric turns into yellow and in base turns bright red. So next, synthetic indicators, methyl orange and phenolphthalein are the synthetic indicators. For example, in acid, methyl orange turns into pink color and in base it will become turns into yellow color. Now another synthetic indicator is phenolphthalein. It turns in acidic, remains colorless and in base it turns into pink color. Next one is olfactory indicator, that means substances which change their smell, odor when mixed with acid or base. Onion paste or juice, vanilla juice, clove oil. These are the examples for olfactory. Smell based, odor based indicator. Suppose in bases, onion juice loses its smell, and in acid there is no change. It doesn't change its smell in acids. Litmus papers about in acids, red litmus paper, how it turns its color. Let us know. When we dip a red litmus paper into HCl, hydrochloric acid, what will happen? Let us see. There will be no change, unchanged. In sulfuric acid, the red litmus paper, no change. In nitric acid HNO3, there is no change. In acetic acid, there is no change. So, red litmus paper, when we dip into acids, there will be no change. It is simply remains red. Suppose a blue litmus paper, a dip into acids, what happens? Let us see. HCl, when we dip blue litmus in HCl, turns into red, and sulfuric acid also turns into red. HNO3, the blue litmus turns into red. In acetic acid, the blue litmus paper turns into red. So, acids turns blue litmus into red. Next one, bases. Bases, blue litmus. Let us check. When we dip the blue litmus paper in NaOH, sodium hydroxide, or in potassium hydroxide, or in magnesium hydroxide, in ammonium hydroxide, what will happen? There will be no change. Blue litmus paper is like blue. KOH, no change, and magnesium hydroxide, no change, ammonium hydroxide, no change. When red litmus paper dip into NaOH, what will happen? It turns blue. KOH turns blue, and red litmus paper dip into magnesium hydroxide, it will become blue, and the red litmus paper dipped in ammonium hydroxide, it will turn blue. So, bases turns red litmus into blue. So, final conclusion, blue litmus turns red, acid turn blue litmus to red. So, bases, about bases, red litmus turns into blue. Let us check. Red litmus turns into blue in bases like this. So, bases blue, acid red. This is the mnemonic about litmus papers. Methyl orange solution. In acids, methyl orange solution turns into pinkish color, red color. and in bases remains yellow. So, methyl orange solution turns red, pinkish red in acids and remains yellow in bases. Phenolphthalein solution. In acids, it is colorless. In bases, the phenolphthalein solution turns into red or pink. By filling this one blue litmus, let us fill this table. Blue litmus paper in acid becomes red and in base there is no change. Red litmus paper in acid there will be no change, but in blue litmus paper turns in bases it turns into blue. Base blue, acid red. In methyl orange, acid turns into pinkish red. And in base remains yellow. By testing phenolphthalein, which is acid and which is base, when we drop some phenolphthalein drops into acid, it is like colorless. In base turns pink or red. So, these are the conclusions by the above Thank you very much for watching this video. Please subscribe my channel, like my channel. If you have any doubt, put a comment in comment section. Thank you once again.